Hello everybody, welcome to this Onshape tutorial. In this episode, we're going to take things up a little bit. We're going to, notch things up. We're going to be creating this Raspberry Pi enclosure cover here, building on a lot of lessons we learned from the first video, i.e. using sketches and extruding to create functional parts in Onshape. So join me, let's get it. Before we begin, let me communicate some of the requirements that we have for this Raspberry Pi enclosure cover. The Raspberry Pi that's currently running all of my smart home services, my home assistants and scripted, currently lives in this enclosure here. But I require a bit more functionality from this enclosure. I need a bit more headroom on internal headroom here. So, because on this channel we're also somewhat frugal, in addition to us being creators, I decided to redesign the top part of the Raspberry Pi enclosure to give me that internal headroom. Before we proceed, I should point out that this enclosure uses four M2.5 flat edge screws. I think they're about 8 mil long to screw onto this threaded holes here. So it's actually very secure. We've actually put in a cover on it. So whatever design we come up with for the cover, we need to be able to not only pick up on these four mounting nodes, but also allow us to actually use the existing M2.5 threaded screws to screw the new cover down onto the hole. So let's get to modeling. Thank you for joining me. Like and subscribe to the video, and let's learn something and build this model today. Thank you. All right, let's create our model here. If you need help getting to this stage in setting up a Onshape, refer to my previous video to tell you how to set up an account and register and get up to this point in the video. So as everything we do in Onshape, we'll start with a sketch, and we're going to sketch on the top plane and to rotate into plane view. And what we'll do here is to hide the front and the right plane. So we'll draw a center square here, and we've already given a location since we drew on the origin. We will dimension the top 95, and we'll dimension the sides, which is 63. Next thing we need to do is to sketch our slot, our center recess slot. To do that, we need to add two lines. So we add a center line here, uh, drawn around the origin, and would give it a center to center distance of 20 mil. To draw in our slot, generally is hidden underneath this offset sign here. So if you can see that, you click the arrow next to the offset, and then you can see the slot function there. You click that and you select your center to center line, and you give this a dimension of 55 mil. That's already dimension, but let's do it again. And because we don't want this line really causing any trouble for us, what we'll do is we make the center line a construction using the letter Q, shortcut Q. So that's now a construction line. We can go ahead and exit the sketch and extrude this sketch here. So we select both faces and we extrude downwards. In this case, we extrude up to a depth of 13 mil. We can close that. What we'll just do is make the sketch visible real quick so that we can see the top part of it. And then we extrude this, but we're extruding this the opposite way. We're not going down because we want a total internal space of about 14 to 15 million height. So this goes the other way, and that's extruded up to 3.3 mil. You know, sizes as you feel you need to. Um, we close that. The next thing we need to do is to do our old sketch. So what we'll do is we hide this sketch here, and we can also hide the top plane because we don't need it. We're going to do the sketch on the surface here. Just be careful whenever you are placing a feature on the surface. If you make any changes to that surface, it breaks the whole model. So sometimes for beginners like you, just to kind of keep track, you might be better off actually just sketching on the plane because the plane is actually also on the surface in this scenario. But you know, I'm a pro, so I will sketch on the surface. So you select the surface again, letter N, rotate into plane view, and we want to put the holes for our screw bosses here that screws onto the enclosure. It's important to remember that our screw here is an M2.5 with an head diameter, the D here, of about 4.75. Ideally, we need to recess this hole because if we don't recess it, given this being 13 mil long and the screw being 8 mil, we will not be able to actually pick up on the threads on the enclosure. So we need the hole here to be bigger than the head diameter of the screw, which is 4.7 to 4.5. But to do that, we are not going to get sufficient wall thickness on this face here. So for example, let me just show you. If so now we're now on the sketch, go back into end view, we put a center circle here of clearance hole for that is, let's just say, so let's even actually do the whole size for 4.7. So we dimension the center to center distance, the center distance of the circle. If you don't know how to calculate that, I will leave a graphic up in the video to show you how that can be worked out. So it's 2.35 from the 2.65 from the top. So 2.65, 65. So you can already see we're already getting really dangerously close to the edge of that there. I'll show you how to fix that in a moment, and then we'll also put the center circle to the center of the circle to 2.35 there. So you can see by just the virtue of placing that, we're already on the edge. So if you are planning on printing this, as I'm planning on doing, you don't have enough wall thickness there to actually make this a robust part in there. It will just flake off. So what we'll do is that we will almost outsize this and convert this all into a bus, into a screw bus that we can actually put our screw into. That would allows us to have sufficient clearances for both the screw head, this part here, and the thread. Because again, both of these need to actually clear the hole in order for us to be able to actually um, pick up on the M245 screw threads already on the enclosure. So what we'll do is we will dimension this in order to have sufficient wall thickness around this. We'll dimension this all 8.5 mil. So the next thing we're going to do is we're going to extrude this boss here. So we'll go ahead and exit the sketch window, extrude, and we click on all of the surfaces of the circle. We want to extrude this down, and we want this to be new, and I'll show you why we want this to be new. And as soon as you see me select this as a new, is added a second part in our parts window here. And this is one of the areas where I think Onshape shines the most, allowing you to actually create multiple parts within the part studio. It does this better than SolidWorks, and it just allows you, if you need to build, for example, in the future, a top and a bottom part of an enclosure, you can actually do that in one uh, sketch, in one part studio, right? And you can draw them in relation to each other as opposed to actually drawing them in separate windows. You can do that in SolidWorks too, but I think Onshape does this a lot better. So to give this a length, we will select up to face there, and we'll select the bottom face to make the model actually go from the top to bottom. And we click tick to exit the extrude. But as the astute among you might pick up, we need four of this, right? And I'm not about to draw this four times. So what we do is that we'll actually mirror this new part around the four sides of the model. And this is why drawing around the origin is always a good idea, because you have two center planes there that you can already leverage for that. So what we need to do is we go into our feature window here, and we select the mirror part. Uh, you can do different sets of mirror here, but for this one we're doing a parts mirror because we're mirroring a separate part of this part studio. So we click part mirror. The entities to mirror is that part there, so you can select that from there. You can select it from your parts window. Regardless, it doesn't really matter. And the mirror plane, it will be our right plane because we're trying to mirror on both sides of this, right? So we'll mirror that. um, Here, we still go ahead and select new because we don't want Onshape to combine this yet, because we still want to mirror this onto this phase. So we select new, and then we exit that. And then we will go back again and select a mirror tool. And now we want to mirror these two parts here. Again, you can select it from wherever. The plane, mirror plane in this case would be a front mirror because we want to mirror from this side of the from this side of the part. So in this case, we will click add because we want this to combine this all into one part, and we select the front plane. And now we have our screw bosses on all four sides of the model. So we can go back ahead and the front and right plane just keeps it less messy. And we'll go ahead and put our screw holes into this. So to put our screw holes into this, we will use the hole feature. I will want this to be a counterbore hole. I want this to be a counterbore hole because again, we need to clear both the screw head and we need to clear both the screw thread to be able to pick up on the M2.5 threads on the enclosure that we already have. Because remember, we're frugal on this channel as much as we're creative, so we're trying to use as much as what we have at the moment and at hand without having to actually buy new things. So we'll make this a counterbore hole. So we select the hole feature there. We select the counterbore hole. For the hole type, we click clearance. Clearance for the thread, i.e. this part here needs to clear the hole. And we will select loose. I've selected, so I need to change that to M2.5. So we're going to select loose here just to allow for any kind of shrinkages in the printing. So that's loose, that's a loose thread. And then we go through all. What we then need to do here is we'll specify the counterbore itself, the head, 5.5, a number greater than the maximum head diameter of our screw, which we know can be up to 4.7. So now we know the head is going to actually clear the screw boss, and we select the depth of it. So the depth of it should give us similar functionality to the depth of the previous cover on the Raspberry Pi case, because again, as I mentioned, we want to be picking up on the M2.5 threads in the screw, in the enclosure. So we want to be picking up on this thread here, right, which is already in the enclosure ready for us to use. So we know that this depth here is 13 mil. So we know the O needs to go down to 11, right? So that gives us the required depth for this. We now need to select the center. Since we don't have a sketch here to actually pick up or a point sketch, we can use another feature in Onshape, which is the mate connector feature. So this allows us to pick up of any point here, any point of reference. So what we do is we select the mate selector, and now we're able to select not only a lot of points winner, so we can select all of the center points that we previously made, but the only one we're interested in here is the center points on the O. So we select all of the four center points of our O boss to create our O. There, there, and there. So now that's created our screw boss and O's for us. So this allows us to pick up on the four M2.5 screws on the enclosure. So we'll go ahead and exit that window for us to be able to actually, use the internal space, additional internal height space for this. So to do that, we're going to use a feature in Onshape called shell. So what shell does, think of shell as a shovel, right? As a shovel that you're using to dig a hole. So what you're going to give the shell feature is the shell thickness that you want, which is the wall thickness, which for us is 2 millimeters, right? And then you select the face that you want to shell. And what the shell feature does is it pretty much shoves off everything within these bounds of this hole here, only leaving your required wall thickness here. So we're selecting our wall thickness 2 millimeters, face to shell, and we select that. And now we've created an enclosure inside of our Raspberry cover, which gives us the adequate internal height that we require for this part. So we'll start with the vent holes on the side. To do that, we'll again start with a sketch. So we'll make a sketch on that face there, and to rotate it into plain view. And we'll start with a 2-point line connecting the top face and the bottom face. And as you can see, that's already constrained there because it's connected to two fixed faces. But again, if I make any changes to that face, right, then this constraint is impacted. So you should always be careful of that. We'll make that a construction line with the letter Q. And then what we need to do is I want the ventals to be somewhat slanted because I think it looks better. If you want to make it straight, up to you. So what I'm going to do is I'm going to put another midpoint line here, but what I'm going to do first is I'm going to kind of probe around this line. And you can see that little box there. So that's telling us that's the midpoint of our line here. So again, and it works for most. So I put a line there, right? Again, that's still a construction line and it's blue because again, I haven't really given it any constraint other than the center point of it. So what we need to do is we need to give it an angle and an angle of 25 degrees. So we dimension that and we give that a length of 5 mil. We can also make that a construction line, and as we did before with the slot at the top, we will just go ahead and use the slot feature again. We select that line and we dimension that slot 3 millimeters. So now we have our slot. Um, so this is dashed at the moment because it's assuming it's a construction line. So what you can do is select all of the 4 sides and use the shortcut Q again to convert that into a solid line, and then we can exit the sketch. So next thing to do, as you probably guess, is extruding that surface there. Is extruding that surface there. We want to, in this case, remove and we don't want to use a blind overlay because this can just keep going, and if you put a feature there it removes it. So what we'll go is in this option here we'll go up to, we can use up to next or up to face. So up to next just means up to the next face, or up to face where you can actually select the face where you want it to end, and that's what we do here. So as you can imagine, I'm not about to draw this 20 times, right? So what we'll do is we'll use the mirror feature. So I will go ahead and select my mirror feature here. This is a feature mirror, not a separate part. The feature we're about to mirror is that extrude, and the direction will select that direction there, the top line there. So that gives it a direction on this face. In terms of pitch distance, we can start with, basically we still need to factor in the width of that, right? And having sufficient wall thicknesses in between them. So we'll probably need this width here plus the wall thickness, so which is 3 plus 2, so 5 there. So that's now placed it appropriately, but you can make that slightly bigger. So let's go with 6. And then increase this number until you're happy with the amount of features you've patterned. So let's start with 5, 6. I think we can add one more in there, 7, right? Um, because it's Onshape, right? You can actually do this for the other side too by just clicking centered, and then it spreads that on both sides. Or you can also use, if you don't want to do that, you can use like a second direction if you want to actually do more patterns in different phases. But in this case, we use a centered feature here. So now it's spread that along that face there. We can go ahead and exit that. And we want to reciprocate this on the other side. And again, as you can imagine, I'm not about to actually do the same thing and put a sketch here and do that again, because we can just use our mirror feature to actually mirror this onto the other side. And this is also when drawing around the origin comes in, because I have 3 planes here that are centered around that. So I will go ahead and use our front plane because we want to mirror from side to side there. So what we'll do here is we'll use our mirror feature. Our entities to mirror is the linear pattern. Oh, sorry, we have to select feature mirror first. So we select the linear pattern and we select our original extrude. So it takes everything. And the mirror plane will be our front plane. And now we've been able to successfully mirror that on the other side. Now we have two sets of vent holes on the side of our Raspberry Pi. To do the top vent holes, we're going to leverage another one of Onshape's best feature. You see, Onshape allows the CAD community to actually create custom design features for the Onshape package online. So we're going to be leveraging one of those custom features that's been created by the community. And this one is called fill pattern. To add that, generally at the very end of here, there's a plus sign here to say that with that line that says add custom features. I've already downloaded it, but I can show you how to do that. So you go in there and you type in fill pattern. You search and your custom feature is there. It's that one actually. So that's the one we're interested in. You select it and it adds that to your Onshape window. So to use that effectively, everything is going to start with a sketch. We'll light our front plane right here and then we'll make a sketch on that surface. Let's rotate it into plane view and we want another peel shape. So the peel shape here is the peel shape here is the same geometry as the ones on the side because we want to give some design consistency. So what we'll do is we just draw that around the origin. Uh, as before, we use a center line. We dimension the center to center distance, which is 5 mil. And then we select the peel feature, the slot feature there, and it's already automatically dimensioned that for us at 3. So we click, and that's done. I will advise we make the center line construction with the shortcut Q. And then what we want to do is just extrude that there. We'll remove that from the top. So we go down, remove. Um, just to keep you in good habits, we select up to face, up to that inner face there, and that's created the part. And I think for me, decoratively, I want to add some chamfers in here because it just looks sick. So let's make that 0.25. Actually, let's make that 0.5. Yep, that's that. And now we can use our fill pattern. So we go to the custom feature section. We select fill pattern. Patterns to feature is to pattern. So we have to go ahead and select all of the individual phases here. That and that, and I think that's all of it, right? So the target boundary will be that there, and now direction direction will be that edge, and now it's beginning to form our fill pattern for us. So what we need to do is we need to specify the amount of patterning that we want here. So we select a pattern type. You can select hexagonal, square, diamond, and we select the border. So how far we want it to be away from the border. So we're going to select here. Here we're going to select 2 millimeters, and the distance from each other we're going to select 10. So now is so all it hasn't so it's taking account of the border that you want there, and anything that falls outside of that gets doesn't get patterned, and is maintaining a minimum distance of I think 2 mil away from um, each of the border there. So we've now created all of our top vents. If you want more vents, so we can have a 1 millimeter border, and then it adds more. You can change the pattern size. I personally prefer hexagonal because you can kind of get more within the bounds of it. And um, yeah, so we've created our top vent holes here. So the next thing we're going to do is, add some logos to this, make this a bit more customized for our environment because, that's what we're doing it, right? So to add a text and a logo to our Raspberry Pi case, if you should wish to, um, again, everything starts with a sketch, and And there's a little text feature here. You see text feature here. You select text. You select you draw a boundary. Then you put whatever you want to put here. So I'm just going to put pi in there. Um, so you select text and that. So that's somewhat upside down, but you can still see it. So let's just rotate that. So now you put your pi. I'm not going to bother to try and constrain this, and this is acceptable. This is only one of the few points that I find acceptable for you to have unconstrained sketches. So you click that, and we also want to add a logo onto that face. To add the logo, what we do is we click on Sketch right there, and I've already gone ahead and found the Docker logo and converted that into DXF. There are plenty of online conversion tools that you can use there. So what we do is uh, we select the insert DXF or DWG, and I click the DXF Docker logo there. I click import, and initially it's in there, but it's massive, it's too big. So what we'll do is we'll use this transform feature to not only reduce this to the appropriate size, but also position it. So we'll select that old logo there, select everything, and we will navigate to the transform feature. So it's underneath the pattern feature there. So we select transform, we select the logo. So now it's giving us a bunch of toggles there. So we can move this all around we want to, but what we want to do first is actually make that smaller. So we want to reduce that to maybe 10% of what it was. So we'll do 0.1 there. And now we want to move that. It's kind of hard to see if I zoom in. We want to move that to the appropriate location. So it's still too big. So we probably want to reduce that a little bit more to where we want it. We'll move that, we'll position that at the top there, and we click sketch. So now we placed our logo and we placed our text. And then what's left for us to do is to just extrude that, right? So we come to the extrude feature, we select letters, and we select our logo here. So we should be able to kind of just draw a line and select all of that. Are we missing something? Oh, okay, we selected it a bit too much. We selected some of our pattern feature there, so we close that. Only leaving the logo, and we want that to be 0.5 mil up, and click, and we're done. We've now successfully created a cover Raspberry Pi enclosure cover, and feel free to send this off to be printed and to be used. Thank you for watching this video. Catch you on the next one. Thank you. Like and subscribe.